we are going to look at some rules that govern electron configuration. First and foremost, let's start with the Aufbau principle. Basically, this is stating that we need to build from the bottom up. If you think of it in terms of building a house, I'm not going to begin building the roof without first building a foundation to put my roof on. So when we write electron configurations, how do you know the correct order to go in? And Aufbau's principle can help us with that. Here's a diagram that details each energy level as well as its shape that we now know SRP, S are spheres, P are dumbbells, and D represent the four-leaf clovers. And the arrows tell us the correct order in which to go. So I want to show you here briefly how to create your own Aufbau table. We're going to begin here by drawing the first energy level and its first shape, orbital shape. So 1s. It's the first one, so it only has 1. The second energy level has 2. 2s, 2p. The third energy level has 3s, 3p, then 3d, then 4s, 4p, and 4d. There is technically a 4f. However, for our class, we do not deal with F's, so we just basically erase and ignore the fact that it's there. Continuing with 5S, 5P, and 5D. 6S is where we stop. We do not go past 6S in our class. Now, how do you use this to basically know the correct order in which to go? Well, our first diagonal line is going to go through 1S. So that's how I know that's my first energy level with the S orbital. My second is going to go through 2S, so my next in order is 2S. Second energy level, S orbital, and then 2P, 3S. 2P, 3S. This is the second energy level, and the third energy level is going to be followed by 3P, then 4P, 4S. So then 3P, 4S, then 3D. That's the tricky part. If you're looking at this here, it's going to go from 4S to 3D, then 4P, followed by a 5S. Last but not least, 4D, 5P, 6S. So 4D, 5P, 6S. And that's how you know the correct order to put your energy levels, each sub-level, and build from the bottom up. That's Aufbau's principle. Again, this matches up with our diagram, so we know the correct order to put those in. The other two rules that you should just pause and get these down, and then we're going to talk about them later, is Hund's rule, which basically says everybody gets one, which is talking about an electron first, and the Pauli exclusion principle, which is dealing with the maximum of two different electrons, each with an opposite spin. If you remember, we talked about in the previous video the spin quantum number as the up arrow and the down arrow. This is denoting that each has to be one up, one down. They cannot be the same together. So let's look at drawing an orbital diagram. Again, we're trying to denote where these electrons are around the nucleus of an atom. Let's get some general rules down and practice until it will make more sense. I promise it makes a little more sense after practice. So to begin here, orbital diagram notations, we know electrons are written as those up and down arrows. The up arrow and down arrow indicate the spin of the electron. This is a right-hand spin, and this here is a left-hand spin. So one spinning clockwise while the other spins counterclockwise in their orbital. The energy level and sublevel is written below the box or line, which each energy level is going to be written just as in the previous 1s, 2s. And then we want to represent each orbital as a horizontal line. 1s, 2s. If you think about the shapes, S is a sphere. No matter how I rotate a sphere, it's always facing the same direction. So it only really has one orbital. When we get to 2p, if you remember, the shape of a p orbital is a dumbbell. Well, a dumbbell I can turn side to side, I can turn it vertical, or I can turn it in and out. That's why p will always has 3 different orbital directions. And then our last, if you kept going, it would go 3s, then 3p, 4s, and then all the way up to d. Any d orbital you get to, which is a 4-leaf clover, can be turned side to side, up and down, in and out, left to right, and right to left. You always have 1, 2, 3, 4, 5 orbitals in a d sublevel, 3 orbitals in a p sublevel, 1 orbital in an s sublevel. Then we basically apply the rules that govern electron configurations and move forward. So let's look at our examples here. Let's begin with a simple example such as nitrogen. Nitrogen, we are going to again start with our build from the bottom up. If you remember back or you forget, what order do I go in? You can draw this diagram yourself and produce this line, but this is the order you go in. 1s, 2s, 2p, 3s. So the more you do this, the better you get at it. And our example here for nitrogen. I know I'm going to start with 1s. 1s, then 2s, then 2p. Oh, line's a little out of place there. I know nitrogen's atomic number is 7. Its mass number is 14. So I need to put in roughly 7 electrons, or exactly 7 electrons. I represent electrons as an up and a down arrow. I can put 2 per orbital, so that's 2 electrons, 3, 4, and I'm using the Aufbau principle, starting at the bottom, building my way up. The Hund's rule says everybody gets one, so when I have multiple orbitals, I'm going to stick 1 electron in each orbital, and I'm at 1, 2, 3, 4, 5, 6, 7. When I stick 1 in each orbital, I want to put them all in with the same spin. I could do it this way, or if you had a 2p and you felt more comfortable in putting them as down spins to begin with, you can do that as well. Put them as down spins, it doesn't matter. But that gives you 7 electrons. Let's look at another example here. Let's look at boron as a possible example. Boron, 5 electrons. So I'm going to start with 1s, then 2s, then 2p. 1s with 2 electrons, I'm trying to get to 5. Then 2s, it can hold 2 electrons as well. And then 2p, I only need 1 more electron, so I'm going to put 1 up there. 1, 2, 3, 4, 5 electrons. Again, if you forget what order to go in, jump back to the example here. You can follow this chart, and this is the correct order if you ever forget. So now that we've had a chance to look at 2 examples, let's go ahead and try one last one. It's a little bigger here, neon, that has 10 electrons. Again, 1s, then 2s, then 2p. I know that my 1s orbital is going to hold 2 electrons, so 1 up, 1 down. 2s is going to hold 2 electrons, then 2p. Everybody gets 1 first. Then I can go back and double them up, because right now I'm at 1, 2, 3, 4, 5, 6, 7. I need to double them up, so it becomes 8, 9, 10. Neon, which has 10 electrons, I represent that right there with my 10 electrons. Let's try one more that's a little bit larger as an example, chlorine has 17 electrons. Chlorine with 17 electrons, you're going to see here that chlorine with 17 electrons ends up looking 1s, 2s, 2p, 3s, 3p. We didn't need the 3d there, but what's unique about the 3p is that it has 1, 2, 3, 4, 5 electrons in the 3p. If you do not have enough electrons, that one will stay by itself. But what you cannot do, which is a violation of the Hund's rule, so you can't do, let's say for example here, 3p, if you went up, up. That is not okay to do that. You are not allowed to put two in the same. They have to be one up, one down. Make sure you know that rule for orbital notations.